Hey, 7th graders, today's activity is 2.3 and 2.4 populations. Your main focus around this is going to be the sim activity and using that simulation to see how when we change one population in a food web, how it's going to affect the other organisms in that food web. So you guys will be doing a lot of predictions and then a lot of testing your predictions and recording data to see whether your prediction was right or not. Your learning targets for today then are I can predict what will happen to a population of organisms if another population of organisms in the same food web changes. So again, we'll be using that simulation where we're looking at 3 populations, wee bugs, furbills, and green leaves and how they relate to each other. First and foremost, you guys need to open your OneNote up and add these 2 key concepts to your notebook. This should go in the key concepts page under the populations and resources section. So it should look something like this. Here's your populations and resources section. Here's your key concept page. And here are key concepts 8 and 9. 8 says the larger the resource population, so that's, the food source, the more ESMs or energy storage molecules are available to the consumer population. So you guys can kind of think about, why are ESMs important? And, our last lesson focused on, how much ESM or energy we need for a population to reproduce. So think back to our previous units where we talk about, how a population increases or decreases based on the number of births and deaths. So how do ESMs and the size of other populations affect that? And then key concept number 9, the larger the consumer population, so those are the ones doing the eating, the more energy storage molecules it will need. So obviously more organisms need more food. Therefore, it will eat more, causing more deaths in a resource population. All right, so moving back into our assignment. Like I said, this is mostly based around sims. And so I'm going to kind of go through some of these sims for you. And then when we get into part 3, I'm going to show you guys an example similar to what we're doing in class. And then you guys will do the sim on your own, looking at a different set of populations. All right, so for this first part, part 2, we are going to be changing, part 2, we're just going to be kind of messing around in the sim. So we're going to go ahead and open the sim up. Here's your link to right click and open. May cause you guys to sign in. I already have it open here. And then I'm going to do the 3 population mode. So here we go. Here's our 3 population. It's not the intro that we did before. The reason we're using this middle 3 population is because you can see it shows the energy storage molecules. So we took a look at this briefly with yesterday's assignment. All right. So I'm going to select 3 population, not the intro, but the middle selection. This interactive lets you observe the energy storage molecules and the little orange bar beneath each organism. A full bar means the organism has had plenty to eat, and is able to reproduce. So zoom in a bit and observe the wee bugs. Then click on the food web overlay in the bottom left-hand corner of the screen directly below the zoom out option. So let's go ahead, zoom in. You guys can focus on the wee bugs, and then also here is this little food web overlay. So some of you guys may have already done our food web activities from earlier this week. Some of you guys are going to do them later this week. But basically here's your rundown or review of food web. So this shows us the 3 organisms that we're looking at in this ecosystem, and it has it connected by these arrows. So we have the green leaves here, arrow pointing to the wee bug, and then another arrow pointing to our furbills. Basically what these arrows show us are energy transferred through this food web. So we know these little wee bugs are herbivores and they eat the green leaves. Okay, so a lot of kids will try to put the arrow backwards where it's like, all right, this little wee bug eats this green leaf, so the arrow should point this way. Well, that's not true because the arrow shows us which way the energy transfers. Okay, a plant makes its own energy, and then this little wee bug comes along that eats it. So it gets its energy from this green leaf. So the arrow points from the green leaf to the furbill because the green leaf gives its energy to the wee bug. And then likely you guys have your furbill eating your wee bugs. And so again, the furbill is getting its energy from these little wee bugs. What these also show us is the population number. That's these big colored numbers directly under their little icons. And then below you can also see as a population what their energy storage molecules look like. So those are the orange smaller numbers underneath. Okay, so back to our simulation. Zoom in a bit and observe the wee bugs, and then click on the food web overlay in the bottom left-hand corner of the screen so you guys know where that is now. So let's ask this question. How are energy storage molecules represented in the sim? Where do you guys see those at? And then where do wee bugs get energy storage molecules in the sim ecosystem? So again, look at that food web that we just talked about. What evidence do you have to support this? All right, moving on to part 3. Part 3 is the example. I'm going to show you guys, I'm not going to show you guys what you're doing with the green leaves and the wee bugs. I'm going to give you a different example to show you guys how this works. I'm going to model for you guys the change in wee bugs and fur bills, so a different little part of this. So what you guys will be examining in your section is what can change the number of births in a population. Use the sim to find out. So in this one, I'm going to show you guys, or in the example, I'm going to show you guys about the wee bugs and the fur bills. Okay, so I'm going to pause you guys right here. I'm going to go into my sim. I'm going to reset it. And I'm going to pause it right there. Okay, I'm going to kind of tell you guys what I'm going to do first, and then I'm going to show you guys. So again, this is a example similar to what you guys are going to be doing with your part 3, but I'm going to use 2 different organisms. So first thing I'm going to do is I'm going to run the sim for 20 time units, and then I'm going to hit pause. So you can see here my little time units up here. They look maybe a little bit faster than a second, and that's okay. We're just going to refer to them as time units. All right, so here we go. We paused it at 20 time units. And now what I'm going to do is I'm going to change the fur bill population to 100, and I'm going to lock it. So if we click on this little guy over here, I can zoom up. I'm going to increase my population of fur bills clear to 100. So this kind of takes us back to the last key concept that we rewrote, where we have a large consumer population. In order for them to sustain, we're going to have a large resource population for them to eat. So we're going to go ahead, change that to 100, and then we're going to lock it into place. So it says locking a population will prevent the population from changing. So even if they run out of food, you're going to see that their population still stays the same. So they're not really dying off yet. So got it. All right, and then what I'm going to do is I'm going to press play again and run this for another 20 time units. So we're going to see data of what happened before we changed this to 100, and then for 20 seconds after we changed our fur bill population to 100. So I'm going to go ahead and hit play, and I'm going to watch it until it goes to 40. And then we're going to take a look at the graph and kind of see how that change of fur bills affected our other populations. So now I have it paused at 40, and I'm going to go up here to analyze. All right, so here's our graph. We have a couple different features to our graph. We can see, obviously, this little green line here is our green leaf population. This aqua colored line is our wee bug population, and then here is our fur bill population. Another great feature of this is you guys can see this table over on the side. You can see how they changed in their population, or how they changed in their energy storage molecules, how many were died and how many were born, their overall population at different points. So the great thing about this is I can click and drag and look at different times during that 40-second period that we had. Okay, so if I go right here, I can say, all right, here's my population green leaves, my population of wee bugs, and my population of fur bills. If we review back to our run and we look at our little web here, when we're talking about changing our fur bills and seeing what happens to our wee bugs, that's what we would consider a direct change. So if I change these fur bills, they're going to directly affect how many wee bugs we have. However, if we're looking at changing our fur bills and then seeing how that changes our wee bugs, because they're not connected in this food web, they don't transfer energy directly to each other, we would call this an indirect change. So again, we could change our fur bills and see how it directly changes the wee bugs or how it indirectly changes the green leaf, because you know what, they would also have an effect there as well. So that's huge for you guys to understand what a direct effect would be and what an indirect effect would be. All right, so going back to our graph, this is going to be similar to what you guys do in this, except obviously I'm showing you 2 different populations. So when you guys do this, you're going to do green leaves and wee bugs. Okay. And then you guys are going to record some data here. You guys would look at, before our change, what was our population of wee bugs, and after our change, what's our population. So you guys can click and say, all right, after the 20 seconds of our change, we could say our fur bill was still 100. There was no change there. But our wee bug population was at 95, and it was decreasing by about 15 at that moment. We can drag this back and say, all right, at this moment in time right here, that's where we increased our, just before we increased our fur bill population. So we can see, all right, our fur bills were only 31, and we were actually increasing our wee bugs at the time. So that would be the data you guys would record for this is, what's the population at that time before. So this would be before. Our wee bugs would be 112, and we'd be increasing right now. So our population was growing slightly. And then after about 20 seconds of having 100 fur bills, we only had 95 in our population, and we were decreasing by about 15 individuals. So we went from increasing by 2 to decreasing by 15 by having our fur bills increased and set at 100. So that would be the kind of information you guys would record in this table. So now that I've showed you guys that experiment, I just want to go through your guys' experiment that you're going to be doing. So again, you're going to look at two different populations. We looked at wee bugs and fur bills. You guys are going to look at green leaves and wee bugs. So what can change the number of births in a population? Use the sim to find out. In the sim, wee bugs eat the green leaves. So again, notice this arrow. The wee bugs are getting their energy from the green leaves. All right, moving on to the next page, you're going to make some predictions. Wee bugs get energy storage molecules from eating green leaves. What change to the green leaf population could increase the number of births in the wee bug population? So you guys are going to be manipulating the green leaves and trying to increase how many wee bugs are being born. So what do you need to do to the resource population, their food, that would give them more births and increase their population size? So would you increase the amount of green leaves there are or decrease? Use your draw tool to circle one of those. And then move on to this next part. For your test, what will you change? That's going to be the independent variable. So how are you guys going to set up this test? In my test that I showed you, I changed the number of fur bills. Okay, what will you change? Are you guys, to increase your wee bug population, are you guys going to change the green leaves, like it says to do up here? Or are you guys going to change the fur bills? In this case, you guys obviously know that you're going to have to do something to the green leaves because that's our little food web that we're studying here. So we're going to manipulate this little green leaf. So with that being said, are you guys going to choose to increase them or decrease them? That's your independent variable. That's the thing as scientists that you guys are going to change or manipulate. And then what will be observed and recorded? So this is your dependent variable. What are you guys going to look for? When we did this simulation with the wee bugs and the fur bills, we looked for the wee bug population, okay, and how much that population changed, whether it was increasing or decreasing. So what will you do? What will you look for to see how it changed? What are you guys supposed to be changing or looking for? Okay, moving on, here are your directions. So same as I just showed you, you guys are going to use the 3 population mode. You're going to run it for 20 time units, and then you're going to press pause. Open your food web overlay, and then make the change to the green leaf population that you predicted would increase the number of births in the wee bug. So again, how will you change the green leaf population to increase the population of wee bugs? Okay. Observe how the number of energy storage molecules in the green leaf population changes as you make that change. Make a large change to see the biggest effect. So when I showed you guys the example with the fur bills, I maxed it out. I think the most that I could go on that was 100. Let's double check. Yeah, I think that's the highest you guys can go. So I would make a huge change to your guys's green leaf population, whether you decide to increase it or decrease it. The more drastic of a change you guys have, the easier you guys are going to see your change in the wee bugs. So make sure you make as big of a change as you can. If you're decreasing, decrease it to 0. If you guys are increasing, increase as high as you can go. Okay, and then you're going to lock that population in place. Press play and run the sim for 20 more time units. Remember, you ran it for 20, you paused it, you made your change to your green leaves, you locked them in place, and then you're going to play it for 20 more time units, and then go back to that graph and analyze and drag your timeline to see where you guys were at. So remember, you want to see your data before. Okay, here's before we made the change on our fir bills. Yours will look a little bit different because you guys are changing your green leaves instead. So you're going to see either an increase or a decrease in your green leaves. So drag it to before that increase or decrease was made and record your information for your WeBugs. And then at the very end, what's your 20 time units after? So where you paused it at 40, the very end of your guys' graph, time 40 right here. You guys are again going to look at your WeBug population and see, all right, after 20 seconds of you guys running that with your changed green leaf population, what happened to your WeBugs? Okay. All right. And then moving on, here's your data table. So record your data right here and right here and use your draw tool to answer this question. So what did you guys choose to do for your green leaves? Did you increase them or decrease? So increasing or decreasing the green leaf population led to more, fewer, or the same amount of energy storage molecules in the green leaf population. So you guys can pop up that little food web to see how that changed as well. And then after the change, the WeBugs burst, increased, decreased, or stayed the same. So you remember your goal was to increase your burst of your WeBug. So hopefully your answer to that is increase, but look at your data. If you guys didn't have an increase in that, then something didn't go well or right. Okay. All right, moving on, you guys will drag the timeline to compare the number of births and deaths after you made the change to the green leaf population and then answer these questions. After the change, there were more births than deaths, fewer births than deaths, and about the same amount as births as deaths. So you guys can look at that and see, here's your births and deaths. So here's at the very end, here's at the very beginning. You guys can see how many were changing in those, okay? Explain why a change to the green leaf population caused the WeBug population to change in size. Be sure to use births and deaths and energy storage molecules in your answer. So think back to that 2.1, 2.2 assignment where you guys read about why energy storage molecules are important for reproduction, and then tie that in with births and deaths. And then finally, given your results from above, what change would decrease the number of births? So we would want to see a decrease in the population of the WeBug. So would you increase your green leaves or decrease your green leaves? Circle 1, and then explain why you chose that. All right, part 4, you guys are going to be looking at the number of deaths. So this is somewhat similar. It's not going to be quite as complicated for you. So again, you can see our little food web for this ecosystem where the green leaves are giving their energy to the WeBugs because the WeBugs eat the green leaves, and the WeBugs are giving their energy to the fir bills because the fir bills eat those WeBugs. In the sim, fir bills eat WeBugs and WeBugs eat green leaves. Okay, so what changes would decrease the number of deaths? So you'd see less individuals dying, therefore your population would increase in the WeBug population. So you can see there's different ways you can do it. Now we're looking at changing either green leaf or fir bills to increase our population of WeBugs. Okay, so circle 2, that would apply. And then you guys are gonna test your answer out here. So now plan an investigation to test both of these predictions. You guys circled 2 here. How are you going to test that? Okay, conduct your test just like you did in part 2 and fill out the data. That was actually part 3. And fill out the data table on the number of WeBug deaths for both of your tests. So remember, you guys found WeBug deaths right here. So you guys can check that out. If one of your tests was not a correct prediction and did not decrease the WeBug's death, correct your answer. So go back to this slide, erase the one that was incorrect, circle the new one that you guys think will be correct, and go back and test that until you guys have figured out how you can decrease WeBug deaths, thus increasing their population. So here's your 2 data tables, test 1, test 2. Again, if either of those don't decrease the deaths and increase your WeBug population, then go back and redo them, collect new data. And then finally, what changes actually did that? Okay, so what did you come up with for your 2 final answers? And then after the change, the WeBug population either increased, decreased, or stayed the same because there were more births and deaths, fewer births and deaths, and about the same births and deaths. So you have 2 things to circle on this. And given your results from above, what changes would increase the number of deaths? So we'd have more dying than being born in the WeBug population. So you don't actually have to test this one. You're just making a prediction based on what you guys just learned. And then finally, do your wrap up. Do you have any questions? Yes or no? If you have some questions, type them below. But obviously, if it's something that's preventing you from doing this assignment, I know this assignment's kind of intensive, but I know you guys can handle it. But let me know if you guys have questions. And then how do you feel you did on this assignment? 4, 3, 2, 1. Finally, you are done. This assignment is turned from a caterpillar to a butterfly. Good work, and I will talk to you soon. Bye.